Welcome to Teja Statistics. In this class, we are going to learn about the some small sample tests. Okay, and we discussed about the large sample tests also. Okay, very important and easy to calculate of large sample tests. Okay, before going to that, here we have to discuss about the t-test for single mean. What is t-test for single mean? If you want to test a single mean, okay, for the small sample of size, then you can use this t-test for single mean. We have to test whether the samples are drawn from the normal population with the mean mu or not. So here are some assumptions. The characteristics under the study follows the normal distribution, and sample observations are random and independent always. Population variances sigma square is unknown. Let's see the definition and also the calculation and for the t-test statistic. Let x1, x2, x3 and so on xn be a random sample of size n is less than 30, that is small sample, selected from a normal population with mean mu and variance sigma square. Null hypothesis: there is no significant difference between the sample mean and the population mean. H naught, mu is equals to mu naught. And the alternative hypothesis: there is a significant difference between the sample mean and the population mean. You can put it in two-tail test or one-tail test, right-tail test and left-tail test. Level of significance: alpha is level of significance at n-1 degrees of freedom. T-test statistic: in case 1, if sigma is known, then you can use z-test statistics x bar minus mu divided by sigma by root n, follows normal distribution with 0 comma 1. If case 2, if sigma is unknown, then x bar minus mu divided by s by root n, or where s square is equals to 1 divided by n minus 1, summation I runs from 1 to n xi minus x bar whole square. Here is your conclusion that compare the calculated value of t with the tabulated value at alpha, level of significance with n minus 1 degrees of freedom. So here t is greater than of if calculated value is greater than that tabulated value, then we have to reject the h naught, otherwise we have to accept the h naught. This is the procedure. Next, t-test for differences of means also will be the same. Here we are going to compare more than 2 means at a time. More than 2 means at a time in the sense only 2. Okay, here the t-test for differences of means, one single mean for the one sample and another mean for the another sample, 2 means only. Okay, sorry for that. And assumptions: the characteristics under the study follows normal distribution, and sample observations are simply random and also be independently drawn. Next, population variances sigma 1 square, sigma 2 square, both are unknown for that. Okay, let x1, x2, x3 and so on xn1 be the first sample size, and with the size n1, and second sample size n2. Next, let y1, y2, y3 and so on y1 of yn2 be another independent random sample from another normal population with the size n2. Okay, the population mean is mu2 and variance sigma 2 square, or you can put it as y if it is y. Okay, what is null hypothesis? Both means are equal. Okay, the alternative hypothesis: both means are not equal. So level of significance also, and the test statistic x bar minus y bar minus expected value of x bar minus y bar and standard error of x bar minus y bar, follows normal distribution. Okay, here are your values and assumptions and the t calculated value. Case 1, if sigma square value is equals to sigma x square is equals to sigma y square is equals to sigma square, then both are getting common in t calculated. So that is the first case. And second case, x bar minus y bar or sigma squares or values are unknown. X bar minus y bar divided by sigma square of x divided by n1 plus sigma square of y of n2 follows normal distribution. Okay, case 3 also will be the same like this. Okay, so this is the conclusion. If t calculated value is greater than t tabulated, then we have to reject h naught, otherwise we have to accept the h naught. So these are the procedures for the testing the single mean and two means. Thank you.